Hey everyone, let's do this activity called collect the squares. You might be a little confused about this activity at first because it uses terminology different than what I use in class, what I think Mr. Wong uses in class. But really all this whole thing's asking you to do is combine like terms. We're just asking you to practice sort of a review skill today, right? So when I'm on screen 6, I'm pretty sure I'm going to tell my students to skip screens 1 through 5. I think Mr. Wong is going to say the same thing as well. So you start on screen 6. And it says select 2 or more squares, whichever ones you want. I don't know, I guess I'll do 4x plus 1, 9x, and negative 2x. I'm going to select 3. And as you can see, it makes an expression below out of the things that you select. And then you're being asked to write their sum using the fewest number of terms. That's the exact same thing as if I asked you to simplify the expression by combining like terms. So, when it comes to math, there's always like different ways of like stating the same thing or the same skill. And so, yeah, that's what we're doing here. We're just practicing our combining like terms. So when I look at this expression that I've got to work here, I see 3 terms with x's in them. They're going to be like terms. I've got this 4x right here. I've got this 9x right here. And I have this negative 2x, thinking of it as negative since it has that minus symbol in front of it. And so positive 4 plus 9 make 13. But then you throw on that minus 2 or negative 2, whatever, and you get 11x. And then the 1 can't combine with any of the x's, right? So we just bring it down as part of our new simplified expression. And so now it says, like when we're being asked to write their sum using the fewest number of terms, that's what we did, right? We wrote the sum of all these things, and we reduced it from 4 terms, 1, 2, 3, 4, to now only 2 terms. And we can't go any lower than that because the 11x and the 1 can't combine. So our answer here is going to be 11x plus 1. And it shades the ones that we chose for us. Nice purple color. All right, let's go on to the next one. All right, so again, select 2 or more squares and write their sum using the fewest number of terms. Let's do the one with the factoring in here. You might call it a distributive one, whatever you want to say. Let's do this one here. And let's do the one with all the negatives. We'll make it extra challenging. So the whole point of the distributive property, the reason why we practice it and the reason why it's so important is because if you look at this expression here, we want to simplify it. We want to combine all the like terms. But this x right here cannot combine with this x, well, this negative 2x here, because the first x is inside the parentheses and the second one's not. And you can't combine something that's inside parentheses with something that's outside parentheses through addition or subtraction until you get rid of those parentheses. But PEMDAS says we have to do this stuff in the parentheses first. So what options do we have? In comes the distributive property. The distributive property allows us a secondary option. It says, well, you can get rid of these parentheses as long as you distribute that 3 first, and then we'll be free to combine our like terms the way we want. So that's what we're going to do. We're going to distribute that 3. I'm going to write this again over here. 3 times quantity x plus 1 plus negative 2x. I'm going to put that in parentheses. I like that better. Minus 2. So I distribute the 3 only to the things inside these parentheses, not to the other things that are like in other parentheses or outside of the first set of parentheses. And I get 3x plus 1 plus negative 2x minus 2, which we could also think of as plus negative 2 if we wanted, right? Those are the same things. And so, well, we've got some like terms here, 3x and negative 2x. That's going to make just 1x, right? 3 minus 2. So I can write that as just x. You can put the 1 if you want. You can write it as 1x, but you don't have to. I'm going to get rid of that. And then we have a 1 and a -2. When those combine together, you get -1, right? +1 -2, or +1 plus -2. And so what I have is x plus -1, which I can also write as just x minus 1. That'll work. Or x plus -1 will work, whichever one you like better. So I'm going to go with x minus 1. Yeah, I don't know what's going on with me, why I keep having to do that. I oofed it up somehow. It says check your sum and try again. What did I do? How embarrassing. I don't see what I did wrong. 3x plus 1. Oh, geez. Oh, can't believe I did that. Look, I didn't distribute properly. I did my 3 times x, which equals 3x. I didn't do my 3 times 1, which should have got me a 3 instead of a 1. I see students make that mistake all the time, and I guess teachers make it from time to time too. All right, so let's fix it. 3x plus 3, not 1. And so the only thing that's going to change is the 1 at the end of my expression here, right? Because nothing changed with any of the x terms. So we're still good there as far as I know, unless I made some other mistake. But now we have this +3 and this -2. And so when they combine, they're going to make a +1. And so I think my expression is supposed to be x plus 1 instead of x minus 1 like I had before. There we go. We got it that time. Nice turquoise, aquamarine type color. Go on to the next one. All right. So Caleb, hey, that's my best friend's name in real life. Caleb added these expressions, but he made an error just like I did. Find the error and explain why it is incorrect. Okay, so it looks like Caleb selected the top 2. You can see it's kind of hard to see, but these boxes here, the top 2 boxes, are like shaded around their edges. So he's trying to add these 2 here. And so the expression got made here, -2x minus 2 plus 8x plus 8. All right, let's look at his work. Okay, so he shifted things around. He rewrote the -2x and then put the plus 8x next, and then the -2 after that, and then the plus 8. That part works well. I don't see any errors there. And then -2x plus 8x is +6x. -2 plus 8 is +6. So far, so good. Oh, here it is. Caleb said that 6x plus 6 equals 12x. You can't do that. So 1 is a term that has an x in it that means 6 times x. And you can't add just a singular 6 to that and get 12 times x. It doesn't work that way. That would be like saying that, okay, 6 times, 10 plus 7 is the same as 13 times 10, right? Or let me use the actual numbers from the thing. So 6 times 10 plus 6 is the same as 12 times 10, right? I'm just pretending that x is 10. Well, 6 times 10 is 60 plus 6 is 66. But 12 times 10 is 120. So you can't take this singular number and add it to this number that's like multiplying by the variable, the coefficient as we call it. Doesn't work out that way. So what should we write? Something like Caleb combined 6x and 6 to make 12x, but that is incorrect because 6x and 6 are not like terms and therefore can't be added or subtracted from each other. You can multiply them, like you could do 6 times 6x and you get 36x. You can't add and subtract them, it doesn't work that way. All right, let's move on. select at least 2 squares at a time. Write their sum using the fewest number of terms. Collect all the squares. So in this game, we got to keep doing this until we've selected all the squares. If you want, you can literally select them all at once and get it all done at once if you want to add all these things together, right? Boom, 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 boom. Oh, look, it doesn't make the expression for us this time like it did in the earlier one, so that makes it a little harder. How about we do it like in sets of 3? We'll just do the top 3, the middle 3, and the bottom 3. I think that's how I'm going to do it. So I'm going to start by writing the expression myself since it doesn't give it to me. Dang, I need like some water or something. All right, 3x plus 6. That's from the first box. And then I have to add plus x minus 2. And then I add 8 times quantity x minus 3. All right, so whenever you're doing this, if you got a distribution in your expression, in my opinion, it's always best to just handle that first before you start messing with too many other things. So I'm just going to literally rewrite this, except I'm going to have the distribution done at the end to get that out of the way. So 8 times x is 8x. And then I got to remember to do the other part this time so I don't mess up. Oh, I got to remember my x. 8 times 3 is 24, so minus 24, right? Because there's a minus sign there in front of the 3. All right, so now let's collect the x's. We got 3x, 1x, 8x. They're going to make 12x. And then let's see here. 6 minus 2 minus 24 negative. I should say negative instead of minus. What do we get? Well, 6 minus 2 is positive 4. You add that to negative 24. I think you're going to get negative 20. So 12x minus 20. All right, so let's try that. Okay, so that's done. We got a nice pink color this time. So let's clear all that work. Let's do the next row. Negative 4x minus 4 plus x plus 1 minus 2 times x plus 2. So I could have written it as plus negative 2x, sorry, negative 2 times x plus 2, but I knew that plus negative and minus are the same thing. So it didn't really matter if I wrote it as minus 2 times quantity x plus 2 or if I had gone plus negative. Just depends on how you like it. Oh, I guess I should tell the thing that I'm selecting these 3. All right, let me get the distribution done first. So I got my, oh, I need my drawing tool. I got my negative 4x minus 4 plus x plus 1. And then the negative 2 times x gets me negative 2x. So I'll add negative 2x. And then the negative 2 times this positive 2 gets me a negative 4. So I'll add negative 4. And now let's put it all together. We got negative 4x, positive x, and negative 2x. So the negative 2x and the negative 4x, they make negative 6x. But then when you toss on this positive 1x, you wind up with a total of negative 5x. And then let's do the regular numbers now, the constant terms as we're supposed to call them. Negative 4, positive 1, and another negative 4. So let's see here, the 2 negative 4s make negative 8, but the positive 1 makes it negative 7. So I'm going to go with negative 5x minus 7. And we got it. All right, the last one, I bet we can do without even writing it out. Look, there's a 7x and a negative 8x, right? So combined, they make negative 1x, which I can just write as negative x. And then we just got that plus 6. I don't even need to write that one out. That one's easy. All right, we did it. So we got to do it again. It's a little harder this time. I'm going to see if I can do this in 2 moves. I'm going to select, first I'm going to select all the ones that have distributive property in them, like this. Make it really hard on myself. And then I'll do one that has all the other ones. So let's write this out. I'm going to use this whole long part of the screen here. I'll move some other stuff out of my way so I got plenty of space to write. We got -4 times quantity x minus 5 plus 6 times quantity x plus 1. Okay, plus -1 times quantity x minus 9. And then plus 7 times quantity 2x plus 1. All right, now I'm going to distribute each one of these and rewrite it as like this really long thing below. So -4 times x is -4x, and -4 times -5 is +20. All right, so now let me do the next one. 6 times x is 6x, and 6 times 1 is 6. All right, and then next, -1 times x is -x, so -x. And then -1 times -9 is +9. Next, we got 7 times 2x, which is 14x, and 7 times 1, which is 7. So there's all our pieces. Now we just add the x's up, add the numbers up, and we're done. So let's do the x's first. -4 plus 6, that puts us at +2, minus 1, so now we're at 1 positive x. But then we throw that 14 on there, and we get 15x. All right, and then now the constant terms. 20 plus 6, that's 26, plus 9, that's 35, and plus 7, that's 42. So I think we got 15x plus 42. Let's try it. There we go. All right, so now let's do all the other ones that don't have factoring or distributive property in them. Looks like we got 4x minus 20. It almost looks like some of these are very close to the ones we had in the previous one, but like what used to be positive is now negative. And I wonder if you were to select these all just right, it comes out to 0. I almost wonder if this is going to come out to like negative 15x minus 42 instead of plus or something. I don't know. Let's see. All right, so 4x minus 20 plus 3x plus 12. Let's see here, plus negative x. We'll write it as plus negative 12 instead of minus 12. You can do it either way. Then plus 8 minus x and minus 2x. So I mixed it up in there. Sometimes I wrote plus negative, sometimes I wrote minus, because those two things mean the same. You just kind of switch back and forth between them. All right, let's just do the x's first. We got positive 4x plus this right here makes positive 7x. Take one away, so we're back at 6x. Take another one away, we're at 5x. Take 2 more away, we're at 3x. All right, now let's do the constant terms. We're starting at negative 20. Let's just add the negatives first, that makes it easier. So we got negative 20 plus negative 12, so that's negative 32. But then when you add this positive 12, we're back to negative 20. And then this 8 is going to make it negative 12, right? Yeah, because these two just cancel each other out. And then negative 20 plus 8, negative 12. So I think that's going to come out to negative 3x minus 12. Where am I supposed to write this up? Oh, I didn't click on any of them. That's why it doesn't know what I'm doing. There we go. 3x minus 12. There we go. Are you ready for more? Yeah. Okay. Describe to a classmate how to write an equivalent expression with fewer terms. All right, so this is the type of question that so many 7th grade students get wrong. Like, this is a big trick one. This is the one that, like, if me or Mr. Wong were to put it on a quiz, we would expect to probably mark over half of our students wrong on this if I had to guess. What happens is that people mess up this part right here for various reasons. There's lots of different ways this could go wrong. Some people will think that they're supposed to do the 5x minus 2 first, and they'll write like 3x or just a 3 or something. Some people will forget to distribute the negative and just do 2 times 6x and 2 times negative 4 or minus 4, and then their positives and negatives will turn out all weird. Or some people like double distribute the negative. What they'll do is they'll distribute negative 2 to 6x and get negative 12x like they should. And they'll distribute negative 2 to negative 4 and get positive 8 like they should. But then they'll write a minus sign in front of all that because there was a minus sign here, not thinking, oh wait, I already took care of the minus sign by distributing it. And now my answer should be, everything in front of my new term should be a plus sign. So let's talk about it just from the beginning. The first thing I want to do is distribute because of PEMDAS. PEMDAS says do the stuff in the parentheses first. We can't, because I can't do 6x minus 4. They're not like terms. Okay, then I'm supposed to do any exponents. That's what the E is, right? There's no exponents in this. So the next thing is multiply, which is right here. This is a multiplication between the 2 and the parentheses. So this has to happen first out of everything I see. I am going to read this as 5x plus negative 2 times this stuff. Okay, so I'm even going to just rewrite it. 5x plus negative 2 times 6x minus 4. All right, and so I need to distribute this negative 2 to the 2 things inside the parentheses there. And whatever comes out from those distributions should have a plus symbol in front of them, and then they're positive or negative, like on their own, like more merit or whatever. So let's just bring the 5x down. We're not doing anything with that yet because we're dealing with the distribution that's later in the expression. And then I'm going to add negative 2 times 6x is negative 12x. So it's plus negative 12x, or just minus 12x. What it shouldn't be, though, is minus negative 12x. That's a mistake that some students would make. All right, and then it's going to be plus negative 2 times negative 4, which is positive 8. So it's just plus 8. Now I can combine the x terms, right? I've got 5x plus negative 12x. That makes negative 7x plus 8. All right, so I guess we're supposed to describe how to do this, right? So I would say first distribute, first rewrite minus 2 as plus negative 2. Then distribute the negative 2. People say like through the parentheses, meaning like to each thing in the parentheses. We can write it like that, to each term in the parentheses. Bring the 5x down. Now combine 5x and negative 12x to get 7x. The final expression is negative 7x plus 8. Oops, I forgot to put a negative sign on this 7x here. All right, I think that's a pretty good description. Maybe there was probably a better way to write it, but I feel like that's good enough. All right, let's do one more, the cool down. Write each expression with fewer terms. Oh, this is easy stuff. Yeah, I guess that's why it's cool down. 10x minus 2x is 8x. And, so this one's, they're trying to trick you. So I think I talked about this earlier in the video, or I might have talked about it in a different video earlier today, I forget. But what we have here is 18x minus everything in the parentheses, minus 7 and minus 4x. And so what this is saying is, hey, look, I want to subtract a bunch of things. And rather than writing a bunch of individual minus signs, I'm just going to write minus all this stuff. And in order to get rid of these parentheses so we can combine that 4x with that 18x, we have to do something that people call distribute the negative. What that means is, like, you're allowed to write a 1 multiplying anything in any expression or any equation ever, right? Because you can multiply anything by 1. It just stays what it already was. You're not changing anything. So I'm allowed to just put a 1 here and say this is 1 times this stuff in the parentheses, right? But now it says 18x minus 1 times this stuff. Well, I can write minus 1 as plus negative, right? So I want to think of it as 18x plus negative 1 times all this stuff. And when you multiply things by negative 1, it just changes its positivity or negativity. If it was positive, it becomes negative. If it was negative, it becomes positive. And so we're going to distribute this negative 1 through the parentheses just to change the sign of the things in there. And that's going to get rid of the parentheses. And people call this distributing the negative, right? Because if you just think of this as a negative sign right here, it's like we're just distributing that through the parentheses, and it's like flipping each thing inside. And so we have 18x, instead of like a positive 7 here, this is now a negative 7. So we write plus negative 7. Instead of a plus 4x, this is now a minus 4x or plus negative 4x, whichever one you like. And so we get 18x minus 4x plus negative 4x, whatever. 14x plus negative 7. You can also write that as minus 7, right? So basically, you just have to think of it as like, okay, I'm starting with 18x, and I'm going to subtract all those things in the parentheses. So I got to subtract 4x. I got to subtract 7. And let's put the answer, 14x minus 7. I think we got it. Let's see. Let's check all the answers here. Oh, how did this make you feel? I don't know. Is there an emoji for like needing to clear your throat 82 times? What is that? Is that this? I don't know. All right. I guess that's it. We'll see you next time. Bye.